In this video, we'll discuss how to safely install batteries, battery chargers, overcurrent protection, and safety disconnects to power your Elco system. Once your batteries are connected, it's easy to plug together the other Elco system components to be fully operational. With proper installation, your Elco EP motor will provide safe and reliable service for many years. Elco sells both inboard and outboard motors. While the voltage and amperage requirements may vary with each Elco motor, the same installation procedures apply to all Elco motors. Elco inboards and outboards run fine on any brand of battery having the correct voltage and amperage capacity, and because battery and charger technologies are rapidly advancing, Elco does not make any recommendations on manufacturer brands. The number of batteries you install will depend on the Elco EP motor being used. Batteries are like the fuel supply for your motor, and battery cables are like the fuel supply lines. Similar to any fuel system, batteries and cables must be the correct size and capacity and installed correctly to ensure safety and reliability. Elco emphasizes that all electric cabling and wiring must be done in accordance with the American Boat and Yacht Council guidelines. The ABYC publishes these guidelines in a Standards and Technical Information publication. These guidelines are found in sections E10, E11, and TE30. TE30 pertains specifically to electric propulsion systems. You should become familiar with the standards or work with someone who is knowledgeable before commencing work. When you finish your installation, you may want an ABYC certified electrician to inspect the work. Remember also that Elco technical staff are available to assist you. At the conclusion of this video, we'll provide contact information. A few words about batteries in general. You have choices for batteries and choices for battery manufacturers. There are primarily two battery types recommended for Elco systems: absorbed glass mat, or AGM for short, and lithium. Other battery types are available, but the basic installation will be the same. Both AGMs and lithium types offer many sizes and storage capacities. AGM batteries are a lead-acid technology without the liquid found in flooded wet cell batteries. This has several advantages over the traditional flooded wet cells, which are not recommended by Elco. AGMs are spill-proof, meaning that the electrolyte is absorbed in fiberglass mats sandwiched between the battery plates, so there is no danger of spilling acid, even if the battery is punctured. AGMs do not emit explosive gases in any appreciable amount. They are vibration and impact resistant to damage, can be rapidly discharged, and have high charge acceptance rates. They are more expensive than flooded wet cell batteries, but less expensive than lithium. They are also larger and weigh more for any given amp-hour capacity rating compared to lithium types. While not required, AGM battery arrays can benefit from battery management systems, or BMS for short. A BMS keeps the batteries and cells balanced for a longer battery life. There are other maintenance and charging considerations for AGM batteries, and you are advised to contact the manufacturer of the brand you are using to be knowledgeable of their recommendations. A BMS can be added without changing the hookups we are instructing in this video. Lithium batteries come in a variety of chemical compositions, with lithium as the primary active chemistry. Like AGMs, lithiums are spill-proof, vibration tolerant, and impact resistant to damage, and have high discharge and recharge rates. They are lighter than their AGM counterpart and have a higher usable storage capacity for their size. As mentioned, they are more expensive, but lithium batteries have many more use cycles than AGMs and are immune to damage from over-discharging. They require a BMS, which monitors each battery and analyzes information to control charging, discharging, and safety protections. Deciding which battery type is best depends on your operating duration requirements, your vessel's available space and weight capacity, how often you use your boat, and your budget. As mentioned, battery technology is advancing and new choices are emerging. Remember that according to ABYC guidelines, no equipment other than the propulsion motor may be powered from the propulsion batteries. All other DC-powered equipment must be powered from other batteries, often referred to as house batteries. When you purchase an Elco EP motor, installation and owner manuals are provided. The installation manual contains a wiring diagram which illustrates what we explain in this video. Confirm your motor voltage requirements by referring to the identification plate found on the motor casting. We are using an Elco EP1200, which requires 48 volts DC. There are 48-volt lithium battery packs available for this application, but we will use AGM batteries instead. 12-volt batteries are wired in series to achieve the required voltage. When connected in series, the voltage of each battery is added, so we'll connect 4 12-volt batteries for the required 48 volts. This does not increase the amp-hour rating of the string, which remains the same. If your runtime requirements exceed the amp-hour rating of your single 4-battery string, you can add a second string, which would be connected to the first string in parallel. This is called a series parallel configuration. A parallel string of batteries doubles the battery amp-hour rating, but keeps the voltage the same. A third string connected in parallel triples the amp-hour rating, and so on. Connecting one string to another in parallel is accomplished by connecting the first battery and the last battery of each string. One thing to keep in mind is that battery strings cabled together in parallel must have equal cable lengths. Even minor differences in lengths can affect the discharge and recharge rates of each battery, and over time will lead to imbalanced battery capacities. The condition will continue towards greater imbalance and will diminish the overall capacity of the battery string. When cabled correctly, you will most likely have extra cable length for batteries closer to the bus bars in order to match the cable length for batteries farthest from the bus bars. Try to place the bus bars so that the cable lengths are optimized to shorter lengths. Also, all interconnecting cable lengths within battery strings must be equal length. This is particularly important for AGM installations to maximize battery longevity and prevent damaging batteries. Determine where your batteries will be located. If there are any fuel tanks on board, avoid placing batteries above or below the tank or any fuel lines. Since batteries will add weight, you may want to experiment to find the best location for optimal weight distribution. Both AGM batteries and lithium batteries allow you to place batteries at different angles or even to be laid sideways. Telecommunication type AGM batteries have a longer but narrower shape and can help maximize available space. They may have a slightly less amp-hour rating, but might be a good choice for constrained spaces. Once batteries are placed, they must be secured. Securing each battery to prevent movement greater than 1 inch in any direction is the general requirement. Refer to ABYC section E10 for more specific information on battery securing guidelines. It's important that all batteries should be the same type and the same size. New batteries should be used in new installations and never mixed with used or aged batteries. Next, you will need to determine the correct battery cable size. Sizing battery cables is a function of two primary factors. The first is the amperage rating of the Elco EP motor for sustained operation. The second factor is distance. If your batteries are placed an extended distance from the motor, the cable size may need to be increased to limit the voltage drop to no more than 3%. The operating ambient air temperature is something to also consider. If high temperatures will exist in a closed compartment having a generator engine, for example, a heavier gauge cable may be needed. Marine-grade battery cables are to be used exclusively. When making battery cables, be sure to also use marine-grade crimp lugs such as these, crimped with a professional-grade crimping tool. This is no place to cut corners or purchase bargain products. Remember that the battery cables have the same function as a fuel line to a combustion engine. Undersized, unprotected, or poorly laid out cables will limit performance and can be a safety hazard. Proper crimp connections are essential for efficient energy flow, which prevents energy loss to heat or possibly even fire. Follow instructions from the connector manufacturer, and once the connection is made, test it by giving it a hard pull, which would typically equal 20 pounds or greater. The final step is to apply heat shrink tubing to cover the cable end of the lug. Be certain to also use the correct type and size lugs for the battery connections. These batteries use a bolt through the stud, but this can vary depending on the battery type and manufacturer. Be sure connections are tight, and if the batteries are not in a protected area, cover each connection with insulating caps to prevent accidental shorting. Once again, refer to ABYC E10 guidelines. If your system of batteries exceeds 48 volts, or you are connecting additional battery strings of 48 volts and higher, ABYC guidelines call for disconnect plugs at no more than 48 volt intervals so that the system may be safely serviced by disconnecting batteries. You will need to install one or more battery chargers depending on your battery array and battery manufacturer recommendations. Charging algorithms of the charger must conform to the battery charging requirements. Available shore power and the rate of charge desired will be factors in selecting the size of the battery charger. Battery chargers provided by Elco are factory set to properly charge many AGM batteries using established algorithms. If you are purchasing a charger from another source, be certain the charger uses the correct algorithm for your batteries. Additional battery strings may require installing a higher output charger or a second charger. Chargers must be matched in output voltage to the battery system installed. For example, a 48-volt battery bank will require a 48-volt charger. A second battery bank connected in parallel will require more charging capacity, which can be accomplished with a second charger connected in parallel. If your vessel has a gasoline-powered generator or other gas motor aboard, the charger must be ignition protected certified or installed in an area having no communication space with the gas-powered motor or fuel supply tank. Mount the charger securely to a bulkhead or other flat surface using guidelines of the charger manufacturer. Selecting a good location may require a compromise because of limited spaces in many vessels. The best location will include all of the following: a place that is well above any normal water accumulation level in the bilge and isolated from the outside weather and water. A place having adequate fresh air and circulation. An overheated charger will slow the charging rate or shut it down altogether if temps reach high enough levels. Avoid placement in a compartment with stowed gear that could restrict airflow or allow objects to come in contact with the charger. Place as close to the batteries as practical. Just as distance from the batteries to the motor should be minimized, so should the distance between the charger and the batteries. Longer distances may require larger cable sizes to overcome voltage losses and heat. The AC power leads for the charger can be connected in different ways depending on the vessel. For smaller boats having no shore power connections, install a standard grounded AC plug to the charger lead and plug into an appropriately sized and grounded extension cord. This circuit should be GFCI protected at the power source on the dock. For larger vessels where AC shore power inlets are installed, refer to the ABYC guidelines for connecting into the AC distribution system of the vessel. Whichever method is chosen, it must be properly grounded and protected with a fuse or circuit breaker in a manner consistent with ABYC guidelines and local codes. After installing the charger, observe lights during charging to confirm that they move through the cycles as intended. For emergency shutoff, AL-KO recommends the use of a high-quality battery disconnect of sufficient capacity like this mushroom switch. The disconnect switch must simultaneously disconnect both the positive and negative conductors of the battery source, and it must be located in an accessible location. Fuses must be installed in the circuit to protect against accidental shorting and for safety. AL-KO recommends using marine-grade inline fuse blocks like this one, securely mounted in a safe and accessible location, and as close as practical to the positive battery conductor, which should be protected by a sheath or cable loom in exposed areas. Circuit protection is needed in 3 places. First, a fuse is installed between the plus bus bar and the battery string. If more than one string is used, a fuse is installed for each. The second place is between the plus bus bar and the battery charger. Again, if more than one charger is used, a fuse is installed for each. The third place is between the emergency disconnect switch and the plus bus bar. All of the current conductive parts must be isolated from the vessel's bonding system, if equipped. The non-current conductive parts, such as the motor casing and casting, should be connected to the vessel's bonding system. Use a green number 4 cable from the motor casting to the grounding bus bar. After being properly fused and bonded, the positive and negative conductors from the battery bus bars will be terminated in an Anderson connector which plugs directly into the AL-KO motor on the side of the motor casting. With all connections in place, plug together the AL-KO pre-wired harnesses to test the system. All of the components have unique receptacles, so there's no chance of getting an incorrect plug into a receptacle. No cutting, soldering, or wiring tools are needed. It's all been pre-wired and tested at the factory. Plug batteries into the AL-KO motor and you should be operational. Test the motor at different speeds and inspect all the connections. Refer to the installation manual for further testing and sea trials. For your reference, this drawing shows all the installation components that we've discussed in the video, except for the 48-volt disconnects, because this system doesn't exceed 48 volts. The drawing appears on the AL-KO website for your review. We hope this video has helped to answer questions about the battery and battery charger installation. Additional questions can be directed to us by email or by calling us during business hours, Eastern Time.